As you may know, light is the fastest thing in the universe, 186,000 miles per second. A flight on an ordinary plane around the Earth would take about 50 hours, while a flight around the Earth at the speed of light would only take 0.134 seconds. But is it possible to travel even faster than that? Well, we can certainly try. This is an idea called faster-than-light travel, or FTL for short. This is what powers the coolest space stories, like Star Wars, where ships like the Millennium Falcon defy the rules of nature with their hyperdrive engines. Or think of Star Trek with its USS Enterprise and its warp drive. FTL would allow us to explore all the uncharted galaxies, maybe even meet some extraterrestrial life. In 1905, Albert Einstein introduced his theory of special relativity. This theory revealed some very important ideas. We learned that FTL travel could lead to some weird consequences. Let's imagine that you're in a starship and someone is standing still and watching you from the outside. You try to go faster than the speed of light. To the observer, it seems like something really weird is happening to your spaceship. As you go faster, they see it like a sausage, squishing and getting shorter and shorter in the direction you're moving. This squishing effect is what scientists call length contraction. This isn't the only weird effect. Relativity also tells us that time starts acting really weird when you go that fast. As you speed up, time slows down for you compared to someone watching from afar. So, the faster you go, the slower time feels for you. For you, it feels like just a few minutes have passed. But back on Earth, years have flown by. And if you have a family member patiently waiting for your return, that person ages a lot more than you do. So, when you finally come back to Earth, you might see that they became very old while you haven't aged at all. This is called time dilation. We can observe this effect even in some everyday things. For example, in our GPS devices, who are connected to satellites way up high in Earth's orbit. The satellites move incredibly fast in space. This causes signals to speed up slightly. For the satellites, time passes a bit differently compared to clocks on Earth. So, the faster you go, the more time dilation grows, which means when you go FTL, time might decide to go backwards. This happens because the math says you end up with a weird -2 result. In other words, going faster than light can actually lead to an accidental time machine. This opens a room for different problems and paradoxes. For example, let's say you showed up in the past and see yourself. Your own past self looking back at you. So, if you high-five them, who started the high-five idea in the first place? There's also a famous grandfather paradox. For example, if you go back in time and accidentally stop your grandparents from meeting, this means your parents are never born, so you shouldn't exist either. Sort of like the movie Back to the Future. But if you don't exist, how could you have gone back in time to stop your grandparents meeting? Or the bootstrap puzzle. Imagine you travel back in time and give Beethoven his own music before he even writes it. He becomes famous for that music, but where did it really come from? Did you make it, or did Beethoven give it to you? All these crazy questions make us rethink how time works. However, these aren't the only things the theory of relativity teaches us. It also says that real life isn't sci-fi movies, and the way we understand how the universe works makes it pretty tough to do the FTL stuff. There are several reasons for that. First, when you travel so fast, you really bend the fabric of space-time. So let's imagine space-time is a big flat piece of fabric. Objects with mass, like planets and stars, create dents or depressions in this fabric due to their gravity. In the normal way of traveling through space, you move along the fabric, following its curves and dips at a speed that's limited by the speed of light. But if you want to exceed it, you essentially need to find a way to cheat the rules of the game. You'd be like a magician who can warp or bend the fabric itself to create shortcuts. Basically, you fold the fabric in such a way that two distant points on the sheet come close together. This creates something called wormholes. Think of them as secret shortcuts that could connect different parts of space. If we could figure out how to use these wormholes, we could shortcut from one point of the universe to another. However, we haven't found any in space yet, and we have no idea if they can even exist at all. Another trick is that if you start going faster and faster, your spaceship gets heavier. It's like trying to sprint with a backpack filled with rocks. The more you try to run, the more tired you get, the heavier the backpack feels, making it harder and harder to pick up speed. No matter how much you push, you can never quite reach the speed of light because your spaceship's mass, its weight, keeps increasing into pretty much infinity. And finally, there's the photon paradox. Photons are tiny particles of light. The reason we see things is because photons reach our eyes. But when you decide to go FTL, these little particles quit their jobs. What happens next is a big mystery. Maybe your spaceship and everything inside falls apart into dust. Everything inside your ship probably goes haywire and causes pure chaos. All these things show that no matter how hard you try, you can never outrun the speed of light. Which is why most scientists think going faster than light is probably impossible, as well as time travel and all that good stuff. But there are still those who dream about it. For example, in the 1990s, Sergei Krasnikov had come up with the Krasnikov tube, pictured as a kind of super-fast subway for space travelers, where you can hop in and zip to your destination in a flash. But as you can see, we haven't built it yet. The problem is we need something called negative energy. Negative energy is a strange kind of fuel that only exists in math problems, not in real life. So until we figure out how to make this make-believe fuel, these amazing spaceship ideas are still just dreams. And to build something like wormholes, we would need a negative mass. This is exactly what it sounds like, an object that not only doesn't weigh anything, it has a negative weight. What in the world does that mean? We have no idea. The main thesis is that if you pushed an object with negative mass away from you, it would accelerate towards you instead. And we really need that to teleport from one point of the universe to another. So, until we create this super weird thing, we won't be able to do that. Another scientist named Eric Lentz also made something like a warp bubble, but it would take an incredibly huge amount of energy, like eating hundreds of Jupiters. However, NASA is still really interested in his idea, and they're hoping to solve the energy challenge with new discoveries. Meanwhile, a group of researchers from the University of Adelaide has been working on finding a way to bypass Einstein's equations. They want to remove the light speed limit entirely, and their early results show promise. Well, let's see if they figure it out eventually. In any case, traveling faster than light is still a wild dream and a big mystery. For now, we have no idea how to do that without breaking the laws of physics. But that doesn't stop us. We'll see what scientists come up with in the future. Until then, please have patience waiting in line at the airport for your flight.
You know how Stephen Hawking said, the best evidence we have that time travel is not possible and never will be, is that we have not been invaded by hordes of tourists from the future. But what if these tourists come to our time, but they do it secretly? You may even have met one of them. Let's see the most famous time travelers. Meet Orin. He's a cyborg who came to us from the year 2050 to stop the coming end of the world. In 2020, he appeared on a TV show where he said the whole world was inside the Matrix. Then he hit the headlines and gave an interview to a popular YouTube channel. As proof that he's a cyborg, he demonstrated his robotic voice, which can be made in a simple computer program. He also called himself We because he declared himself a collective consciousness that had come to save humanity. Orin became famous for his predictions about the near future, but it turned out that many experts had already announced these forecasts earlier. He also said that a huge corporation was suppressing humanity, and we were inside a complex computer simulation. If we don't improve or care for each other and nature, the end will begin in 2050. Orin no longer appears on major shows, but he has a small fan base of people who love all sorts of fantastic theories. Another time traveler is Adam Archin, who came to us from 2045. There was an interview with him on YouTube where he shared some details about the future of the US, after which the video went viral and hit the lines in many newspapers. Archon reported that the last official president of the country would be the daughter of Martin Luther King III, and she would become the greatest US president in history. Another exciting event that Archon announced is supposed to happen in 2028. He said that people would learn about the existence of extraterrestrial civilizations. He added that these creatures wouldn't come from outer space. The traveler also noted that the world would switch to a single digital currency and all cash would disappear. Of course, no one believed him, so the experts conducted a lie detector test. And Adam Archon successfully passed it. He said that he had a chip in his hand to facilitate time travel. An extraterrestrial civilization would arrive on Earth in 2028, and in 2045, people would be closer to robots. The lie detector didn't state that Archon was lying, but this doesn't mean he told the truth, since the device can be deceived with the help of special training. In any case, in 2028, we will find out whether Archon was right or not. All these time travelers arrive in the past and, for some reason, don't use knowledge from the future. What would you do if you could go back 50 years? Perhaps you would invest money in shares of some young company that will become a big, expensive corporation. In that case, everyone would believe that you really came from the past. And by the way, one guy did it. He invested $800 in the stock exchange and made $350 million out of it. This guy's name was Andrew Carlson, and he hit a big jackpot in 2003. However, he didn't manage to enjoy a rich life because the FBI came for him. Andrew sold some stocks and bought others, and did this very successfully. Thus, in a few months, he became a millionaire. The Securities Commission couldn't believe in such coincidences, so it called the FBI. During the interrogation, everyone was sure Andrew would begin to justify himself and say he was lucky. But instead, he calmly replied that he came from the year 2256 with the help of a time machine. Of course, no one took it seriously. But when the FBI started looking for information about this man, they found nothing. Andrew Carlson had no documents. He was not in any database. He just appeared out of nowhere and started making a lot of money. He was interrogated for about 4 hours, and he behaved pretty calmly. It seemed as if he was telling the truth. However, he didn't tell them the time machine's location. When the press found out about this man, he immediately became a celebrity. Well-known news sites began to write about Andrew Carlson. Articles have appeared in Japan, Australia, Germany, the UK, and other countries. And of course, journalists started calling the FBI to find out more details about this guy. And the FBI told them that the whole story was fiction and that there was no Andrew Carlson. Information about him appeared on an internet resource known for its fake news. At some point, the article about the time traveler somehow got into Yahoo, where it went viral. So, as we see, all statements about time travelers are either fiction or a lie. Conversations about such travels appeared thanks to fantastic films and books. Pop culture has greatly influenced this fantastic concept and created several theories claiming that time travel is real. And some people believe that, especially those who are far from science. But what do real scientists think about this? Are such trips really possible? Let's try to find out. Scientists say, yes, time travel is real because we're now traveling in time. Time is moving forward, and we're moving with it. We call it a journey. But if we need to get into the future or go back to the past, everything is much more complicated here. Remember Einstein's little theory of relativity? It says that time moves relative to the observer and has no constant value. To understand better, here's a simple example. 10 hairs on your head. Is it a lot or a little? 10 hairs in a bowl of soup. Is that a lot or a little? everything is relative and depends on the conditions. The same thing happens with time and space. If we move at a tremendous speed, close to the speed of light, then time slows down for us. The perception of time becomes different for a person who's running and for one who's standing still. If we're near some heavy object, let's say 1,000 times heavier than the sun, then the time next to this object also slows down, thanks to its strong gravity. In this sense, time travel is possible. If you're an old person and meet your friend as young as he was 50 years ago. "Why are you so young?" "Oh, I've been flying in space at a tremendous speed all this time, that's all." But this doesn't mean that this friend just sat on the ship for 50 years and didn't age. No, time was different for him. 10 years for you on Earth is a long period of time, but for him, these 10 years passed like half an hour. Gravity and speed bend time. For this reason, astronaut Scott Kelly, who spent a year and a half in orbit, became 5 milliseconds younger than his twin brother after coming to Earth. All this time Scott spent inside the ship flying in orbit at high speed, and he was also further away from the gravitational center of the planet. So, time was slower for him by 5 milliseconds than for his brother. Objectively, time always runs at the same speed, but its speed changes inside the perceptions of different observers under different conditions. That's what the theory of relativity is about. But what about jumping into the future or the past, like in movies? Wormholes will help you with this. This is something like tunnels that pass through space and time and can connect different time segments in different places in the universe. They are like cheat codes that can break the laws of the universe. Wormholes are elusive, have different sizes, are unpredictable, appear in space, and vanish. But their main problem is that wormholes only exist in theory and sci-fi and have never been noticed in our universe by scientists.
Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of 2 identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with 2 identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe: light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself, regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly.